Okay, good morning again, Professor David J. De Los Reyes. Okay, it's August 2023. The time is 3:20 EM. Okay, my long video format discussion again, next one. It will be alternating current circuit, and this will now be lesson number 25. And the title of the discussion or the topic is Superposition Theorem. Superposition Theorem is actually the third advanced solutions of circuitry, okay, in the computation of current passing through any given load. Okay, this will now be an advanced circuit solution. Okay, let's proceed. Okay, the subject matter for this morning, August 2023, Alternating Current Circuit, lesson number 25. The title of the discussion will be Superposition Theorem. This will be the third one. We are now through with the Thevenin's theorem. We are now through with the Norton's theorem, and this is the third one, Superposition Theorem. Okay, the application of this superposition theorem is that this is being used for a multi-source circuit, meaning if there are too many voltage sources, like if you are connecting two alternators in parallel, serving a load, common load, okay, the configuration will be something like this. This should be generator number 1, generator number 2, and connected across the terminals is a load CL. Okay. The question is how much current is that passes through load CL due to source number 1 and source number 2 with this given configuration. Actually, we could change the configuration. Okay, I place it here minus plus, this is minus plus. So meaning to say, initially, when this generates voltage and this generates voltage, it will start here. The positive alternation will start here. Okay, this will be the alternating voltage. This will start same as this one if this is plus and this is plus, meaning to say when they give a alternating voltage, the first initial rush of current is like this if this is plus, right? If this is plus, the initial rush of current due to this will be like this. Then for the next alternation, it will reverse. I am not saying that this is plus what you call this this is plus what you call this at this steady state location, right? Because for alternating current, sometimes this is plus, this minus, and this is minus, this is plus, okay? This is the plus first portion, this is the negative other thing, right? So it alternates. I just put the designation plus and minus, so we know where is the starting point of the current when it initially generates voltage. But of course, it is alternating. Positive alternation is like this, negative alternation is like this. So don't be mistaken by this like in the polarity of a battery, right? Because this terminal here could either be plus one time, other times this is minus. Because it's alternating, right? And this is plus. This one plus one time, this negative, this plus. Okay? Okay, let's continue. The problem is how to solve for the current passing through load CL due to alternator number 1, no, number 1 in alternator number 2. Okay, I will erase this one so it will look nice. Okay? The problem is asking what will be the current passing through load CL due to alternator number 1 and alternator number 2. So this superposition theorem is actually applicable for multi-source circuit. Okay? If it's only a single source, okay, I just use the Thevenin's and Norton's theorem. But for a superposition theorem, okay, at least there will be two alternators in parallel. Right? At least two. Because if this is nothing, okay, I'll just use the ordinary method of solution. Right? But if there is two, we could not do anything about it to compute for the current. We must have to stick to the rule of the so-called superposition theorem. That's why superposition theorem is actually concentrated on circuits that is multi-source circuit. At least two alternators in parallel. Okay, let's try to bring out the procedure on how to compute for the current passing through load CL due to source number 1 and source number 2, meaning alternator number 1 and alternator number 2. Okay, I will try to read the procedure. Take one source at a time while the others are short-circuited and being replaced by their internal impedance. Calculate the current being supplied to the load and take note of its direction. Meaning to say, if we try to take the current passing through load C1, same figure, okay, due to E1, we will try to short out source number 2. So if we short out source number 2, it seems there is no more source number 2, right? But if there is an internal impedance due to source number 2, okay, if there is an internal impedance, consider in the calculation, if there is, right? Because if we short out source number 2, this will be gone, right? And the internal impedance, this is Z internal. Try to include this in your computation because there is an effect of this internal impedance, right? If there is nothing, theoretically, okay, you just short it out. Okay? So the configuration will be like this. Right? But if there is an internal impedance due to generator number 2, put it here, CI number 2, meaning internal impedance due to generator number 2. If there is. But if there is nothing, this is just a pure line, right? Okay? That's what that is the meaning of the so-called others are short-circuited and being replaced by their internal impedance. Meaning in the calculation of the current due to E1 through CL, if there is an internal impedance for generator number 2, place it here. If there is nothing, nothing will be placed over here. Okay? So if we try to compute for IL1 now, okay, it goes downward, okay? If initially this is plus, of course the initial current passing through IL1 will be downward, right? And in the next alternation, it will go up again. So we are just taking the first direction, the significance of this, right? So this is IL1, the direction of the current due to E1 passing through ZL. The direction is downward. Okay? Number 2, after considering all the individual voltage sources to find the current passing through CL, okay, it's like this. We'll consider source number 2, source number 1, number 2. We consider already source number 1, we shorted source number 2, okay? So we'll put back source number 2. This is plus, this is minus, and this is E2, right? If we try to compute for the current coming from this, passing through CL, considering E2, we short out source number 1, right? If we short out source number 1, this will be gone. right? So it seems we are just given a series parallel circuit with one voltage source. Try to compute for the current passing through CL due to this. Okay, so if this is plus initially, of course the initial rush of current through CL will be downward. Okay, it will be downward like this. So due to this, when this is plus, the first initial rush of current passing through CL will be downward. Of course, when it alternates, okay, it will go like that. But we're just taking note of the first, okay, in rush of current. So due to E2, the current passing through ZL will be downward. Right? Okay, these are now the summary of the how to compute for the current. If the current passes in the same direction, okay, after considering voltage source number 1 and number 2, to compute for the current passing through the load CL, if the current passes in the same direction, okay, the current passing through ZL, that will be IL, and it should be equal to I1 plus I2. It will be the summation. Okay? Summation of the current. If D go or if D passes through CL in one direction, the total current passing through CL should be the summation. It should be I1 plus I2. Okay? Supposing the opposite direction, supposing I will place it in. This is E1, right? Supposing I will change the polarity of this one. Initially, this is plus, and this is minus. So when we consider this one, the current passing through CL initially, the initial inrush will be upward, right? So it will be the reverse of the second source, right? So if they are opposite in direction, the net current passing through load CL should be I bigger minus I smaller. Okay? If the downward is bigger, okay, and the upward is smaller, assuming we change the polarity of that one, okay, the upward is smaller, IL now will be I bigger minus I smaller. Okay, which is bigger? You subtract the smaller from the bigger one. If the direction of the current are opposite to each other. Okay, that's how we compute for the current passing through load CL if we are given two voltage sources. So if they go in one direction, the total current passing through CL will be I1 plus I2. If they are in opposite direction, it should be the bigger current minus the smaller current. Oh, that's superposition theorem. And the computation of the current value I1 and I2, okay, just use your knowledge of Ohm's law, right? Because if you consider E1, of course, you short E2. So what's coming out? It should be a series parallel combination. So using your knowledge of series parallel combination, actually you could compute for the current passing through ZL due to E1. And again, if you consider E2, okay, this will be GAN. Okay, if you consider, if you consider E2, this will be GAN. Again, this is a parallel, series parallel connection. Using your knowledge of Ohm's law, you could compute for the current passing through this. And if the current, again, I will repeat it for the last time. If the current passes through the load in one direction, okay, the total current passing through that load will be I1 plus I2. And if the current are against each other due to E1 and E2, it should be the bigger current minus the smaller current, that is IL. As simple as that one. That's superposition theorem. Okay? So the concept here is that take one source at a time, compute for the current passing through load CL, take note of the direction, and again consider source number 2, okay, compute for the current, and take note of the direction. Okay, case number 1. If the current passes through the load in the same direction, the total current passing will be the summation of the current. It should be I1 plus I2. If they are opposite in direction, okay, assuming they are opposite in direction, the net current passing through that load CL, it should be the bigger current minus the smaller current. Okay, that's it, guys. That's superposition theorem. So for those of you who are taking up electrical engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.davidj. If you want to share it, please click share. Try to watch my long video format discussion on alternating current circuit. I will assure you, you will learn something from it. Okay, good morning from Los Angeles. Professor David J.